In this video, we're going to construct a 1 minus alpha times 100% confidence interval for the difference of two means, where we're talking about independent sampling methods. A simple random sample of size n1 is taken from a population with unknown mean mu sub 1 and unknown standard deviation sigma sub 1. Also, a simple random sample of size n sub 2 is taken from a population with unknown mean mu sub 2 and unknown standard deviation sigma sub 2. If the two populations are normally distributed, or the sample sizes are sufficiently large, meaning both sample sizes are greater than or equal to 30, a 1 minus alpha times 100% confidence interval about mu sub 1 minus mu sub 2 is given by: the lower bound will be x bar sub 1 minus x bar sub 2 minus t sub alpha over 2 times the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. And the upper bound will be x bar sub 1 minus x bar sub 2 plus t sub alpha over 2 times the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2, where t sub alpha over 2 is computed using the smaller of n sub 1 minus 1 or n sub 2 minus 1 degrees of freedom. So this is going to work like constructing other confidence intervals. Our point estimate will be x bar sub 1 minus x bar sub 2, and this is our formula for the margin of error for this scenario. So t sub alpha over 2 times the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2, that's going to be the margin of error. So we'll find our point estimate minus the margin of error and our point estimate plus the margin of error. Let's take a look at an example. Visual versus textual learners. Researchers wanted to know whether there was a difference in comprehension among students learning a computer program based on the style of the text. They randomly divided 36 students of similar educational level, age, and so on into two groups of 18 each. Group 1 individuals learned the software using a visual manual, multimodal instruction, while Group 2 individuals learned the software using a textual manual, unimodal instruction. The following data represent scores that the students received on an exam given to them after they studied from the manuals. So we have data for the students who used the visual manual, and we have data for the students who used the textual manual. And again, these are representing the exam scores that they received after studying from the appropriate manual. We're supposed to construct a 95% confidence interval for the mean difference in test scores for Group 1 versus Group 2. So we need to find a 95% confidence interval for this set of data. So if I bring back the data, first of all, we have data, and so we're going to need to calculate the mean and the standard deviation for both the visual manual and the textual manual students. So I'm going to use my calculator to do that. So if I go to Stat and Edit, I have already entered these data into my calculator. So I have the visual manual data in list 1, and I have the textual manual data in list 2. So I'm going to do Stat and Calc, and I'm going to do two variable statistics because I have both the visual and the manual data. So my X list is list 1, my Y list is list 2, and so if I calculate, so X bar is 62.85, that's the mean for the visual manual, and S sub X is 12.03, so let me write that down. So X bar 1 is equal to 62.85, and S1 is equal to 12.03133,262. Now, for the second set of data, that's called Y bar and S sub Y, so I'm going to call that X bar 2 and S2. So X bar 2 is going to be 54.35166667, and S sub 2 is 9.2242433792. So I'm going to write those down. So X bar 2 is equal to 54.3516, and then the 6 repeats, and S sub 2 is equal to 9.2242433792. And I think I'm going to round these to like 5 places each so that I'm not carrying it out completely this far. Now that may produce a tiny bit of error, but not much. Now we're wanting to construct a 95% confidence interval. And so in order to do that, we're going to use the t-distribution with the lesser of n1 minus 1 or n2 minus 1 degrees of freedom. Now in this case, both of our sample sizes are 18, so 18 minus 1 is 17, so we're going to have 17 degrees of freedom that we're going to use for this t-distribution. So I have a t-distribution, and again the degrees of freedom is equal to 17, and so we're doing a 95% confidence interval, and so that means the area here in the middle is 0.95 and the area in the two tails is the other 0.05, and so half of that's going to go in this tail and half of that's going to go in this tail. I'm going to need to calculate the critical values so that I can calculate the confidence interval. Now I can do that by using the t-table from the back of the book, by using inverse t on my graphing calculator, or by using the t-calculator in StatCrunch. I'm going to use the inverse t command on my calculator. So I'm going to distribution inverse t. The area in the left tail is 0.025, and we have 17 degrees of freedom. And so I get a critical value of negative 2.110 if I round to 3 places. So this is negative 2.110, which means this is positive 2.110 by symmetry. So I'm going to calculate my margin of error. So my margin of error, again, is going to be t sub alpha over 2 times the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. That's going to be my margin of error. So that's going to be 2.110 times the square root of, and again, if I round to, say, 5 places, that's going to be 12.03133 squared over n sub 1, which is 18, plus, if I round to 5 places, this is going to be 9.22424 squared over, again, 18. So I'm going to calculate that. So if I bring in my calculator, I have 2.110 times the square root of 12.03133 squared divided by 18 plus 9.22424 squared divided by 18. So that gives me 7.540 if I round to 3 places. So this is approximately 7.540. So that's my margin of error. Now my point estimate is going to be the difference between x bar 1 and x bar 2. So if I take x bar 1 minus x bar 2, that's going to be 62.85 minus 54.35167 if I round to 5 places. So if I do that, 62.85 minus 54.35167. And so that is 8.53433. So this difference is approximately 8.53433. 0.53433. That is my point estimate for the difference between the visual and the textual manual students. So my confidence interval is going to be that point estimate. So that's going to be 8.53433 minus 7.540 to 8.53433 plus 7.540. And so if I do that on my calculator, 8.53433 minus 7.540, that is going to be approximately 0.994. I'm going to round to 3 places now. So 0.994 to, if I do 8.53433 plus 7.540, that is going to be about 16.074. 16.074. So I'm 95% confident that the true mean difference between the visual and textual learners is somewhere between 0.994 and 16.074 in terms of their score on the exam. So there is a difference in their score on the exams, and that difference is somewhere between 0.994 and 16.074. So it does appear that the visual manual students did better on average than the textual manual students. That is statistically significant based on the fact that 0 is not in that confidence interval. Now, we can also do this directly on our calculator, and we can also do this directly in StatCrunch. So let's take a look at how to do that. So I already showed you that I had this data entered into my calculator. I have the visual manual students, or group 1, in list 1, and I have the textual manual students, or group 2, in list 2. So if I go to Stat and Tests, then in this particular case, we have a 2-sample T interval. So that is option 0 on my calculator, a 2-sample T interval. So if I go there, I can either input the information with data, or I could have the summary statistics. In this case, I have data, so I'm going to select that. List 1 is L1, list 2 is L2, so again, that's the visual manual students and the textual manual students. I'm doing a 95% confidence interval, and I do not want pooled, so I'm just going to say calculate. Now, when I calculate this with my calculator, I get a different result than what we got when we did it by hand. When we did it by hand, we got 0.994 to 16.074. With my calculator, I'm getting 1.2183 to 15.778. So what's up with the difference? Just like when we were doing hypothesis tests, the difference is in the degrees of freedom. So we used 17 degrees of freedom for our calculation, but the calculator is using 31.85 degrees of freedom using that more complicated formula. So that's the reason for the difference. Now, if we use StatCrunch, I've already entered my data into the 2 columns. So I have the visual manual data, I have the textual manual data. So we can go to Stat and T-Stats. We have 2 samples. In this case, we have data, so I'm selecting that. So sample 1, that is the visual manual students. Sample 2, that is the textual manual students. In this case, we're doing a confidence interval, and I want a 95% confidence interval, so that's set. All I have to do is say compute. When I do that, I get the result 1.218332, that's the lower limit of my confidence interval, to 15.778335. That's the upper limit of my confidence interval, and those results agree with the results from the TI calculator. Again, that's slightly different from what we got by hand, and the reason for that difference is because of the degrees of freedom used by technology, whereas we use the degrees of freedom which were the lesser of n sub 1 minus 1 or n sub 2 minus 1. So this is how we can construct confidence intervals either by hand or using technology when we're looking for a confidence interval for the mean difference between two independent samples.